Hello Bloomfield High and welcome to Mr. Wood's awesome math class. Today we're going to be working on rational expressions and being able to use the factoring concepts that we learned on the previous video and being able to add, subtract, multiply, and divide fractional components that involve factoring as well. On the first problem that we're going to be talking about, we're actually going to be discussing concepts about domain and also being able to simplify it. So the first thing, let's go ahead and actually simplify this down to the most that we possibly can. And so I'm going to end up getting 60 over 12, which I know is 5, and x cubed over x, which ends up being x squared. So this simplifies down that way because 60 divided by 12 is 5. And x cubed over x, just subtract, right, to give me x squared. Now, does this have restrictions for the x or the domain? Remember the domain is what can the x values be. So what are the possible, so we want to know what are all of the possible x values, and that is what the domain is. Well, most of the time domain doesn't have restrictions. X can be any value. But in this particular situation, we know in math, like for instance, what is 3 divided by 0? We know that 3 divided by 0 is undefined, right? So if something has a 0 in the denominator, we know that is considered to be undefined. So in our problem, we have to evaluate, and we only care about, really, for restrictions, the denominator. What does the denominator happen? So at what value of x? So if I set the denominator equal to 0, because I know I cannot have a 0 in the denominator, because 0 in the denominator goes to unrestricted. X can't. So in this case, x cannot be equal to 0. But x can be any other value except 0. So this we call a restriction. And this we also use the term, and I'll be referring to this later, we call that an asymptote. So this has a restriction, x cannot be 0, which gives us an asymptote, or sometimes gives us like a hole. We'll be discussing what that really means later. So the proper way to write this out would be 5x squared. So the answer is 5x squared, but where x cannot equal 0. Number 2 here, so if I'm looking at this second problem, I want to go about evaluating this. Well, in order to actually divide these out, I need to first factor this whole bottom. So let's go ahead and factor that out and see what does that give me. And so I got an m and an m, I got a 7 and a 3. And so I get 3 and 7. Is there a way to make a 4? Absolutely. In order for it to be plus, this has to be positive. This has to be minus. So that has to be minus. That has to be plus. So on the top, I have m plus 7. On the bottom, I have m plus 7 and m minus 3. And I can see now those will divide out. So my answer simplified is 1 over m minus 3. However, for restrictions, I don't just care about the simplified denominator. Here I know if I set that equal to 0, so if I set m minus 3 equal to 0, what would that be? We know m can't be equal to 3 in this case. But what happens to this m plus 7? That's also going to be a restriction because that is part of my original denominator. So the other part of the denominator, m plus 7, or if I set that equal to 0, m can also not be equal to negative 7. So the final answer would be, it's 1 over m minus 3, where m cannot equal a negative 7 or 3. Right? So here we go. What I want you guys to do, try now to pause it at this point and try the next 2 on your own and see if you can figure out the answers. So this one I want to factor the top, and I'm just going to do that here. So if I factor the top, I have a p and a p, I have, let's try 5 and 2. Does that make a -3? Yep, I'm going to have a -5 and a +2. So that's going to simplify down to p minus 5 np plus 2. That would be our numerator. Let's see, how does the denominator break down? So I want to do the denominator. I have a p and a p. I got a 1 and a 2. In order to make a +1, the middle term, this has to be +1, and has to be -1. So I have a p plus 2 and a p minus 1. And I can see the p plus 2 will divide out. And so my answer simplified p minus 5 over p minus 1. Well, once again, I do have to take into account the entire denominator for my excluded values for the domain. So what can p not be equal to? So in this case, p cannot equal to -2 or to 1 because I can't have a 0 in either of these locations. So if p is 1, that gives me a 0. If p is -2, that gives me a 0. So this would be the final answer. Okay, so for the very next problem, let's go ahead and once again, let's factor this top so I can see that this is going to factor into, and this time I'm just going to put it side by side. I got x and x, and I can say, all right, well, that's going to be 3 and 2, 3 and 2. In order to get the, so that's going to be plus, that's got to be minus. So there's my numerator. Let's do the denominator. I got to have x and x. Let's try factors of 15. Let's do 5 and 3. Can I make it 8 with that? Absolutely. Plus and plus. I can see that x plus 3 divides out. So I'm going to get x minus 2 over x plus 5, where x can't be equal to, and if I once again set these equal to 0, so x plus 5, if you set that equal to 0, just move the 5 over. So x can't be -5, or x can't be -3. And there's your final answer. All right, so looking at this problem, the very first thing I want to do, and always, we just want to factor everything down. X squared minus 16, the difference of two squares. I can say I know that's x plus 4 and x minus 4. And if you don't see that immediately, you can do the technique that we did previously and just break that down by saying, all right, well, I got an x, I have an x, I know I want a factors of 16, let's try 4 and 4. Well, my middle term is 0, so the only way to make the middle term 0 is by making one of them plus, one of them minus. So there's the top. Now on the bottom, I never, ever, ever leave a minus x, because it just complicates life. So instead of making the minus x, I'm going to pull the minus out, and then just change all the signs and make it x minus 9. And over here, then let's factor this. So if I want to factor that out, this is going to end up being x plus 10 and x minus 9. And the bottom is going to end up being x plus 10 and x plus 4. Okay, and then what I want to do is just go through a systematic process of evaluating, see what's on the top, what's on the bottom, and maybe what can divide out. So here I see an x plus 4, and over here I see an x plus 4. So those are divided out and gone. I can get rid of those. Here I see an x plus 10 and an x plus 10, so I can divide those off, and those are gone. I can also see an x minus 9 and an x minus 9. Well, the only thing that's left then is I have an x minus 4 on the top, and I have this negative, where I can think about there's a -1 in the bottom. Well, mathematicians, we don't ever like to have these negatives left over in denominators. So really all you need to do, and you can just think about that, I'll just move it up to the top. So I'm just going to make this a negative of x minus 4, or that's the same thing as saying negative x plus 4. And there's our final answer. except for restrictions. So in this case, the restrictions is anything that shows up as a denominator, any of it. So if I look at any of these restrictions in this case, what can x not be? Well, x can't be what? So if I take 9, so if I take this first piece, 9 minus x, so if I look at 9 minus x and set that equal to 0, what can x not be equal to? Well, x can't be 9. So I know that x cannot equal 9. If I look at the factored piece for this other denominator, which we said was x plus 10, so the other denominator, this denominator here that's factored out, we said that was x plus 10, and that was x plus 4, right? So in that case, what do I get there? What restrictions? Here this says x can't equal a negative 10, and here this says x can't equal negative 4. So all of the values that I can't have, I cannot have x that is equal to a negative 10, a negative 4, or a 9. And there is my final answer. All right, so the only difference between division and multiplication is we know division, we have to either do the KFC procedure, or we keep, flip, change, or I call it, remember I call it the KISS, keep it, switch it, switch it. So all I'm going to do is that process right now. So I'm going to take my v minus 7, the v plus 8. On the bottom I have the v plus 8. I have the v minus 10. And over here, if I switch this to multiplication instead of division, the v minus 10 comes to the top and the 1 goes to the bottom. And now let's just see, what can I possibly cancel out? Well, the v plus 8 can cancel out, the v minus 10 can cancel out, and I'm just left with v minus 7. So all that big mess just ends up being equal to v minus 7. But remember, we're looking also for our asymptotes, or our restrictions on our domain. What can the x value not be? It can be all real numbers except for what? So, and we're looking at anything that was a denominator. Now for division, you have to really contemplate, and all three of these are technically denominators, because here is a divide, and here I'm dividing by this. So if any part of the right side is equal to 0, that's an error. If this bottom left side is a 0, that's an error. So any one of these three pieces will give us a restriction. In this case, the 1 doesn't affect us. And the problem next to over here, these do affect what my restrictions are. So in this case, v can't equal, so here the v plus 8, v can't equal negative 8. So from that part, v can't equal negative 8. For the v minus 10, v can't equal 10. And from the v minus 10, it's the same thing. So there is my final answer, where I have it's v minus 7. Restrictions are v can't equal negative 8 or 10. All right, so in this case, try to pause this, see if you can actually figure